Okay, let's talk about composite shapes and the area of composite shapes. So you can see here on my screen, I have got a funny shape. No, it's not a regular shape. It's actually made up of two different shapes. If you have a guess, I'm sure you'd be able to tell me that what we have here, we should probably have the fact that these sides are all the same length, is we have a square. This part here, we'll call him B, and then we have part of a circle up here, we'll call that A. So now that part of a circle we'll call a semicircle, because that's what that is. So in order to find the area of this composite shape, we are going to need to find the area of its component parts, all the bits that make up this shape. So we'll start with the semicircle. So we have the area of the semicircle, and you'll note that I've written the area rule down because that's important to write every single time that you do an area. You should always show what rule you're using to figure it out. So I have shown my rule, which is here. Now, for a quick review, this bit on the end, 180 over 360, that really is the number of degrees of the circle that I'm dealing with. If I had a quarter of a circle, I would only have 90 degrees out of a complete 360. But here we've got 180 degrees out of a 360 degree circle. So I have then substituted in the next line here. I have my value of pi, my radius over here. Well, I have a width of 50 millimeters, which means that my radius from my center of my circle to the outside edge is half of that distance. So it will be 25 squared, and my 180 over 360 becomes a half. When I calculate that, I get 981.7 millimeters squared. The unit value, if we're doing area, will always be squared. Very important to remember that. Okay, the next part is I will need to find the area of the square. Now we know that the formula, which we always write first, is just side squared. I find my side length, substitute it in, and then I square it, and I get 2,500 millimeters squared. Now, as you could imagine, the last part of my calculation is to determine the total area, to determine the total when I add the component parts together. So when I add them together, I get my final result, as you can see on the screen there. Now, these composite figures that we are finding the area of, well, that one's additive. That one, there's two sections that you add together. Could be 3 sections or 5 sections, whatever. But sometimes, as you can see in this one here, we might have a shape where there's a bit cut out of the actual figure. The process is not any different. Once again, I will suggest that you name parts. So really what I have here, if I look at my shape, is I have a really large rectangle and a small rectangle. So I'm going to call my large rectangle A, and I'm going to call my small one B, and then I'm going to work out the area of each of these. So here's my A rectangle, the area of A, and once again you show your formula that you're using, you then substitute in the values that you use, and then you calculate. Okay, as you can see there. Next part, I will then calculate my area of the smaller section, this B area that I have here, this little bit that's been cut out. Now, because we know that we're removing a shape from a bigger shape, we know that the total area is actually going to be a matter of taking away that small negative space. That was that other shape. And you can see that I've calculated that there. So composite shapes, to solve them, you need to identify the component parts. You need to then name the parts, A, B, C, whatever. You then need to work out the area of each of those parts and then bring it together in a section where you conclude with the total area, whether you're adding parts, taking away parts, all of those different things. Okay, so that is how you find the area of composite.